For the logistic growth model, there's only so much you need to really be aware of and understand. And the first issue is you need to be able to find your carrying capacity. Your differential equation will most likely be given in one of these three formats. Trying to get that to stop. There we go. If you notice that you have a number times p, the population, factored out, and you have the subtraction beginning with a 1, your carrying capacity is the number under population over here. If you notice you have a number multiplied to a p factored out, but in your parentheses you have a number minus just the population p variable, that number in front, that is your carrying capacity. If you have this situation where it's not factored at all, I would say the easiest thing to do is to factor out the entire KP. If you do that, you will create this, and then you just need to figure out what number is in the denominator. So basically you'll have 1 minus something times p. Take that number that p is multiplied by and do 1 over that number. You've got your carrying capacity. Now, what do you need to know? Let me show you. I have this ready to go. This is a question that showed up in free response a long, long time ago. And they sometimes throw a little bit of logistic growth in there. And let me explain what you see. Look at the differential equation. What is the carrying capacity on this problem? Yep, 12 is the carrying capacity. Now, I want you to see that part A, it's giving you two different initial populations. One of them is well under carrying capacity, but a reproducible number. The other one is over carrying capacity, in fact, well over carrying capacity. In either of those situations, as time approaches infinity, your population will head to carrying capacity, period. They have to give you initial populations, because if they don't, there is a second possibility of 0. If you don't have any population to begin with, you can't create a population from no one. So they will give you something they're not going to want. They're not going to give you like initial population is 1 to confuse you. All you're doing is stating the answer. You don't need to explain yourself. You can explain a little bit more if you want, but all they're looking for is you knowing that it's carrying capacity and that you were able to identify it. Now, part B asks another important question, and that is, for what value of P is the population growing the fastest? If you are pre-aware of what they might ask you, you can read this faster, or you'll understand what they're saying more easily. This is referring to the fact that there is a point of inflection on the graph of the solution at a certain number. And let me draw for you that if you're looking at a slope field and this is your carrying capacity, if you look at a solution drawn into your slope field, it could look like this. And I'm trying to show a point of inflection at half the carrying capacity. This model causes that to always happen. So if you are asked anything about growing the fastest, what am I trying to do? I want to draw a tangent line, or I'm attempting to draw a tangent line. You are growing fastest when you are at that point of inflection. And that point of inflection occurs when you are located at half your carrying capacity, and that is your population. So going back over there, they have to give you an initial population, and they are probably going to give you an initial population that is under half your carrying capacity. If for some reason they don't give you initial population under half the carrying capacity, then you are growing the fastest at the initial time. That's when you're growing fastest. So for part B, it was just the answer worth 1 point. After that, it went into here's a different model, and you had a completely different turnaround what you are working on, and it was no longer the logistical model. And let me emphasize also that if you see something that says find the solution to the differential equation, or find the function, who that's a differential equation of. In that part, if you're given both variables, they are expecting you to separate the variables by multiplication division, and then just go through that integration process. And the steps are always an issue of separate your variables, do the antiderivatives, don't forget a plus c. Then use the initial condition, whatever point they give you, use it to find your unknown constant. Now you can find your unknown constant right away, or you can isolate y, play around with the unknown constant, make it change. This is showing that the unknown constant c morphs into a different unknown constant through work going from this step to this step. That's all. It just isn't showing the algebra in between those two. And you just need to use that initial condition to find c or the morphed c. From there, the last thing to do is isolate the function itself. And typically it is worth about 5 points. So it's really important. If you look at it, that's more than your knowledge of the logistic equation. If the logistic model shows up in multiple choice, I've only seen it as one multiple choice problem out of all the 45 problems. So if you put together that this is the most points I've ever seen them give for the logistic model in free response, and then add that one multiple choice is worth 1.2, you're looking at the logistic model being at the most 4.2 points. That is still less than your ability to do this. And it is that important. So when it comes to that, I had some people in first period asked me about that. So the exponential growth decay model, if it is specifically the model that shows up in the AB class, in other words, the rate of change of your population is proportional to the size of the population. If that is your exact thing, realize you're expected to understand how that integration works. And I posted onto Google Classroom. Let me find that. Free response type details. So differential equations. And I believe I put yes, this right here This is what you're expected to be familiar with. It is highly unlikely that this model will show up in free response, but it is decently likely that it'll show up in multiple choice. And if you are familiar with this, you don't need to do this in multiple choice. You know quickly the result. And let me say, forgive me for using a capital K with a lowercase k, but I did. The uppercase K is just the morph of the constant due to integration. So just this is a specific type of problem. When I divide by P, I get natural log of absolute P equals KT plus C. I put both sides to the power of E, and then I have addition in the exponent. That turns into going backward on the rule you're familiar with of when you are multiplying the same base, you add the exponents. Then the plus or minus of the absolute value goes in with the e to the c. Well, you don't need plus or minus if it's population. They might give you something that isn't representing population. So I'm leaving it with the plus or minus. Then you should know that you end up with P equal to some number times e to the kt. Realize that that number is the initial population if it is a population model. So in other words, if you see this and you are told the initial population is 1500 and the value of k is a number that's right there and you can see it, you can quickly go to 1500 for initial population. The k you see up there is there. Boom, you know it, done. It is that quick if you're familiar with this model. I want to point out that what I have written up here is what you can very likely expect as a type of problem that you will need to solve by separating the variables. And that's where you're given a linear formula with a y in it, but you can separate that from the multiplication of a function that has x in it. My advice to you is don't bring the m over to the left side. In fact, I would recommend that you actually, no, I've got a better version somewhere, I think, of this. My advice, before you get started, multiply both sides by m. It'll make the integration not have this extra 1 over m and all the extra excess in here. It makes it a lot easier. Let me just say that. But this is kind of an explanation of how you might work through that type of a problem. So if you run into a free response problem that uses differential equations, most of the time they do ask you to find a particular solution. Make sure that you do all these things. And I'm going to leave it at that. Coming back over to this, I went through a possible example. And so here's a possible example. Let's say you have some k number times x, and it's multiplied by 1 minus y. So you can see this is a slight variation from this exponential growth model in the AB area. So my advice to you is that constant k, do not, oh yeah, and I changed things on it. So let me restart that. So my advice to you is that k, leave it where it is. Don't bring it to the side with the y. Don't let it be where the natural log is. That's my advice. or I should say where you're going to integrate to get the natural log, because it just gets icky. So if this was the problem that you encountered, you would multiply the dx over to the right, and then you would divide the entire factor with the y over to the left. But be careful, because sometimes they give you separate problem, separate, if I'm spelling that correctly. I think I'm not. I don't know. I question myself. Moving on. Let's say they might give you this. Don't feel like they are always going to create a 1 over y dy situation. Think through the multiplication division. If this is your situation, multiply both sides by y and see that it is not the 1 over y, it's a y dy. And then go through your process. So I'm going to stay focused on this particular problem. We divide the 1 minus y over, leave that constant with the simpler side, the side that has the simpler integration. Now, when I go to integrate both sides, you need to think through the u substitution. If 1 minus y is u, the derivative is negative 1. So that means that you are going to end up with an integral that is negative the natural log of the absolute value of u. So be careful of the derivatives of your u's with your u substitution. On the other side, you have some constant times integrate the x. Throw a plus c on. Then the next thing you want to do is isolate the logarithm so it isn't multiplied by anything, because you can't e to the power this and nicely play with the algebra at that moment. It's easier if you multiply both sides by the negative 1. And then e to the power both sides. And I'm going to point out that this is really plus some number. Now the left side is just absolute value of 1 minus y. On the right side, you can take this addition and expand your exponential using that exponent rule. And you know that exponent rule more by the thought of, if it's the same base and I'm multiplying, I add the exponents. After you do that, the absolute value can come off, but when it comes off, it's a plus or minus. If you have a particular solution, if you have a particular point, you are going to get an actual solution where you know your unknown constant. The plus or the minus, one of them works, the other one doesn't for that particular solution, because you have to have continuity through the one known solution point. And this will have a split at y equals 1 with an asymptote, and you can't just cross the asymptote with a specific curve. You don't know where it lands on the other side of the asymptote. It's either the plus or the minus, and you have to figure out which it is. It's easiest if you allow it to be absorbed. So what I'm going to do is I'm going to take my e to the negative c. I'm just switching the order of multiplication. Now, the plus or minus sign, I can actually move it over to here and create one giant unknown constant. I'm just going to put a capital A for that. You can use any letter that isn't already being used. I would recommend that at this moment, you plug in your known point into the x and y and solve for the unknown constant. And again, this is an issue where when you look at the integral just before you integrate, you have a constant divided by a linear function. It must be linear in the denominator. If it is anything else, if it is not linear in the denominator, you are not getting a logarithm. You are using the power rule, where you add 1 to the exponent, divide by that new exponent. Half of the time that they ask you to do the separation of variables on the AP exam, it's the type of integral where you get a logarithm. But there's a whole nother half of the time, and they may give you something different, where it's like this, and you're not getting a logarithm. Also know this. I've seen problems where they add, let's say your dy dx is something involving an addition or subtraction, and you can't, through multiplication or division, separate the variables. They are not going to ask you to solve that differential equation. They will just ask you to do a whole bunch of other things to it. Most likely, you're going to have an Euler method involved. You might have a slope field involved. They're just going to ask you other questions, but you would not be asked to solve. There is an occasional differential equation problem where you don't actually do the separate and solve. So back to the problem. Know that once you find that unknown constant, all you have to do is isolate your y. And I'm just going to leave it at that because you know how to isolate your y. So that said, let me see, what were some of the other important things that got discussed earlier this morning? Related rates. If you're dealing with related rates, you are dealing with something that is asking you to find a rate of change with respect to time. You need to understand that they will have given you one or more rates with respect to time. You need to figure out, like, what did they give you? Did they give you dv dt? Did they give you dh dt? Did they give you dr dt? Those kinds of things. If v stands for volume and h stands for height and r stands for radius, and you are given, say, 2 of these, You are asked to find one. You are given one or more rates of change. You are asked to find another rate of change. That may mean only two of the three. You have at least two, but you might have more than that. You need to make an equation that involves only those variables, v and h. That's what I mean by find an equation with only those variables that you are given a rate of change for or asked to find the rate of change. Once you have an equation, you're just going into implicit differentiation. And let me remind you of the issue of implicit differentiation. So I gave this example. So let's see, y equals sine of x cubed plus x. Let's say this is what you're given, and you know that you need to differentiate with respect to time. None of the variables here are t. And I'm going to show you two ways that you can handle this. And I'm telling you, implicit differentiation is going to show up, and a good enough amount to pay attention. So if it's just solely a variable, taking the derivative with respect to time is just that variable's derivative with respect to time. But if the variable is sitting inside of a big function, you want to think about the chain rule. And you want to recognize that because this is not the variable that we are differentiating with respect to, treat that like a baby function that you are chain ruling. So that means look at this as the sine of blah cubed. If you were taking the derivative of the sine of blah cubed, you would notice that the outermost mommy function is sine of blah. Derivative of sine of blah is cosine of blah. Chain rule says, give mommy her baby and multiply by the derivative of that baby with respect to t. So right here, you are going to need to, with respect to t, differentiate now the x cubed. Now at this point, you still need to look at x as an innermost baby function. You are now taking the derivative of blah cubed. The derivative of blah cubed is 3 blah squared. And again, give mommy her baby, multiply by the derivative of that baby with respect to time. Boom. Then over at the end, I have a plus sign. And then I just have a lone x sitting there. And with that lone x, you're just going to throw out a dx dt. And it's done. Now, this is one way to handle it. But I want to also mention to you, if you have some y equals f of x function, and you're expected to take the derivative with respect to time, you can also do the following. dy dx, which you know to be f prime of x, is the same thing as, do you see what I'm setting up? I've got a dy over dx, but I now split them up with a multiplication sign, and whatever extra variable is involved, I can do this. And then I just realized I said, hold on, back up. Back up, back up, back up. I realized what I did wrong. I said it wrong. You need to find dy dt, but you have f of x. I'm going to split up the dy dt. That's what I was supposed to do. And then x is actually more of an intermediate variable. So to find the derivative of y with respect to t, you could just literally do the derivative with respect to x, but then multiply by dx dt. And I want to show you that that is the same thing, because this dy dt could have been looked at as just take the derivative like normal and then multiply by dx dt. Derivative like normal would have been the cosine of x cubed times 3x squared and then a plus 1. So you can do it either of those two ways. If L'Hopital's rule shows up, on a free response, you must write two separate limits before you L'Hopital, where you are either saying the limit as x approaches a of the top function is equal to 0, and the limit as x approaches a of the bottom function is equal to 0. Or, if they're both infinity, write down both limits individually that they are equal to infinity. Know that taking this class in college, a professor might demand that you do this in a test every time. Other professors will be like, it's okay if you just do 0 over 0, but say 0 over 0. The AP test expects the ultimate. You have to state those. Otherwise, you're not going to get the credit for your L'Hopital. This is very, very important. My recommendation to you in studying for this test is go through the outline and just kind of read over everything. If something doesn't make sense, while we do have the practice exam this weekend, the AP exam, we still have a whole nother week to get those questions answered. And I will work with you on your grade issues after the AP test if the rush of the AP test brought it down. But, within reason. Don't expect the entire world to. Anyway. Be aware of the definitions, the theorems. With the theorems, you have a hypothesis. Make sure you know the hypotheses that goes with them. The extreme value theorem is pretty quick. It just says as long as you are continuous over a closed interval. Can't draw. Even if you have sharp turns, you are guaranteed an absolute maximum and an absolute minimum. Not relative, absolute. Because this doesn't have relatives, or at least I tried to draw something that didn't. That doesn't have relatives, only absolutes. For intermediate value theorem, know the hypothesis. You have to state the hypothesis in your free response. If it's multiple choice, sometimes they create problems where if you don't know the hypothesis, you're not going to be able to answer their multiple choice problem. Intermediate value theorem is saying if you have two y values, one of them is larger than the other, whichever order it is. If you are asked whether there is some number that occurs over the time frame between time A and B, the only requirement is continuous and that number is between the f of A and f of B. If you are dealing with a continuous graph, you cannot get from point A to point B without crossing the n threshold. That is intermediate value theorem. Mean value theorem is looking at the need to not only be continuous over the closed interval, but differentiable over the open interval. It doesn't technically have to be differentiable at the endpoints. And it's saying you have your f of A and your f of B, whichever these two are. The slope between the endpoints must equal the slope for some x in between those two endpoints. So I just drew the straight line. The graph itself is continuous and differentiable. So maybe it's like na 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 na. You have somewhere along here a slope of a tangent line that is parallel. It's maybe about there-ish. And that's where you set the derivative of the function equal to the slope through the endpoints. This blue line has a slope given by this formula. And those do show up on the AP exam. Make sure you state the hypothesis. Know that linear approximation is really just the tangent line. You can use it to approximate other y values. But go through these formulas. For the AP test, they are only going to take you through 2 steps in Euler's method. Just 2. It will be just this much. And that'll be done. I have a lot of detail in here for you to look at and read over. And I know there's a lot here and it takes time to go over it. Maybe you can't get through all of it as you prepare for the practice exam, but that's why I say I might work with your grade after the AP test if this insane, frantic getting ready for the AP test became a problem for you. Because we're really being rushed with this May 4th date. May 4th is the date you would have gotten if there was no COVID. They are pushing the COVID date on us. The no COVID date, I mean. So I'm trying to juggle it with you guys. My main priority is getting you ready for the AP test when that AP test occurs. I understand the practice exam this weekend you may not feel totally prepared for, but just do the best you can. Where is this specifically? You can find this. Bring this over. I've got it all in caps. AP test prep material. This is the outline that I was just showing you. And also, now I lost it. Also in this test prep, I've got, if you want to look at more free response problems pertaining to a particular topic, this lets you know what year and what problem to go to. There sometimes are overlaps, like here in 2012, number 6 was all series, but problem 4, part D specifically did a little bit in there, so I added that in. These are the 4 BC topics that could show up. Know that you will see at least 2 of these, if not 3 of them. Mild chance that all 4 will show up. The testing location is the Mustang Commons. For your practice test this weekend, if you do the online version, you're going to do it at your own time. And then I'll be administering some practice in class on Saturday morning and Sunday morning. If you're able to make it, make sure you let me know so I have enough tests. Know that the second page and the third page are A-B problems, but they might be a BC problem if they've added in things like Euler's method or length, area volume. If it has find the perimeter or find a length of a curve, then it's actually a BC problem. The rest of these tend to be the problems that are shared with the AB test, and they share 3 of them. The real AP test is Mustang Commons. My practice is going to be in my classroom, room 100. Okay. Are we up? What time is class out today? Am I going over time? I'm just trying to find out. You guys are usually quick with this. Oh my goodness. Okay, let me double check. Fridays. Okay, well, I'm going to answer my phone because we are over. And I'm going to stop the recording. If you have a question, hold on. Hey, Devin, can you hold on 1 second? Okay. All right, so